Good morning. Can you hear me okay? So I was a little surprised trying to find who was introducing the presentation, and I didn't realize it was coming from the next room, so that was a little weird, but we are all good. Good morning, and thank you for the opportunity to be here. I'm very glad. It's my first time attending this conference, so very glad to be here with you, sharing some of the things that we are currently doing at our test track facility. So I was told that I could talk a little bit about what we are doing in general, but I'm going to try to focus on research that is currently being sponsored by South Carolina Department of Transportation. So we are going from there. A little introduction, just to make sure everybody is on the same page. So probably most of you know about the test track, but for those of you that don't, our test track facility is a 1.7-mile track. The track was completed in year 2000. So it was built in 2000. In 2000, we started the first cycle. The track has 46 sections. 26 of those sections are on the tangents and 20 on the curves. Most of our research happens on the tangents, but we also conduct research on the curves sometimes when sponsors want to do that. Over the years, we had a blend of different sponsors, a blend of state agencies as well as private sponsors. So up to now, we have approximately 35 plus sponsors, unique sponsors that have been partnering with us to conduct different types of research. For those of you also that are not aware, our research cycle goes in 3-year cycles. So what we do on those 3 years, we start with phase 1. That's the planning. We plan for construction. We build the test sections. After the sections are built, we proceed to trafficking. We applied a total of 10 million easels of heavy truck traffic. So for 2 years, we do that on the sections. At the end of the 2 years, we conduct forensic evaluation. We look at our test results, and we share the results with the sponsors and also with the asphalt industry. And we do that at our test track conference that happens at the end of those 3 years. So right now, at the current cycle, we build the sections in the fall of 2024. We are in the process of trafficking those sections, hoping for the results. So this will be cycle number 9. We are always proud to say that the research that we do at our test track is innovative, relevant, and implementable. We take pride on making our research implementable because we want to make sure that the sponsors get their money's worth with what they are investing on. We focus on mixed design and also on testing different materials, also pavement design and preservation treatments. Our goal at the end is to advance safe and sustainable pavements for the asphalt industry. So I want to share this very quick with you. Last year, in 2024, we published a report, very short report, so don't worry, it's only like 24 pages, but it's pretty neat because it contains key findings from the beginning of the first cycle. So from 2000 to 2024, we have very neat findings over the years. So if you download the report here with the QR code that I presented here, you can find that report available. It is also available in our website. The neat thing about the report is that also it provides the reference to the main report where those findings were actually gathered. So a lot of pretty cool information, in my opinion. So once again, a little bit of our partnership with South Carolina DOT. South Carolina started sponsoring sections during the first cycle, so back from 2000. And it has continued to do sponsoring since then. What type of sections South Carolina DOT has sponsored individual sections where South Carolina is looking at a specific objective, testing a new material, a new mix design. But also South Carolina DOT has participated in what we call multi-state experiments. These are experiments where you have several agencies that have a bigger goal, so several agencies paid to have research conducted on different sections. So So that's a collaborative effort between agencies. Examples of those efforts will be the group experiment and the green group that took place in past research cycles. Currently, South Carolina DOT is sponsoring 2 test sections, and those are the sections that I'm going to try to focus on today mostly. But I want to also point out that South Carolina has been a partner for our pavement preservation group. The pavement preservation group is research that we are conducting not on the test track, but on roads, US 280, back in Alabama, and also on a local road. What we are trying to do with that experiment is to look at different preservation treatments to see the capability of those treatments to extend the life of the pavement. So pretty neat experiment there, and acknowledging also the sponsoring from South Carolina DOT on that. So before I move on, I want to say thank you. Without sponsoring, we will not be where we are today. So we are always thankful to the different sponsors for their support. So as I mentioned, currently at the test track, we have 2 test sections sponsored by South Carolina DOT. A new test section, that's section S8 and section S9, that we are referring to. That one has a traffic continuation because it's a section that was constructed back in 2018. So we are right now on the 3rd research cycle on that section. And I'm going to provide details about the new section S8 and also S9. I'm going to start providing some information about section S9, the section that was built back in 2018. Before I move on that, I want to acknowledge that this research has been, the leader of this research has been Dr. Dave Tim. So a lot of information that I'm going to present today is something that he had been gathering over the past couple of cycles. So the experiment is a thick leaf paving. We know that flexible pavements usually are built in a series of leaves. So you have to realize when you are building different leaves, you have to put tack coat between the layers. Sometimes you have to deal with different materials. It takes time, and it consumes a lot of work zones, right? You need a lot of time to put a structure like that together. Because of the traffic demand that you currently have in South Carolina, working on rapid deep rehabilitations in single layers is something that you've been doing for the past few years. We are talking about layers that are 4 to 5 inches thick. But there was a desire to pave even thicker layers at one time. So that's how the idea came to place a section at the test track and monitoring. And one of the advantages to have a section at the test track is that you can put a lot of traffic, accelerated traffic, in a short amount of time to get results quicker than you would do if you would place that in the real world. Some of the key concerns when the idea came up, the time to cool that layer, right? If you think about it, you are trying to put more than 6 inches of asphalt. So that was one of the concerns, and the capacity that we will have to achieve compaction in the field. Another concern was the potential rotting susceptibility that mix will have once it was placed. So the experiment objective for this thick leaf paving in section S9 was to further develop a rapid construction method to reduce lane closure length on major highways and also primary routes. So once again, I'm going to try to summarize a lot of the information that has been generated since 2018. As I mentioned previously, right now traffic continuation is ongoing. We are on the 3rd cycle for this particular section. As you can see on the right, this section actually was built, has an 8-inch asphalt layer that was built on top of 5 inches of a granular base of local materials, and all that resting on the native subgrade soil available at the test track. So a little bit of information about the actual mix design that we use. This was a Type B intermediate special mix design from South Carolina, rehabilitation, repairs, interstate highways, highway volume, primary routes. That was the special mix that we use. It's a 12.5 nominal max with a PG 64 minus 22. The mix had a 25% wrap. We use warm mix asphalt to produce it. Evotherm was the warm mix asphalt technology selected at a rate of 0.5%. In terms of production, mixing took place at approximately 275 to 280 degrees Fahrenheit. The mix was later compacted to a temperature range of 245 to 250 degrees Fahrenheit. The design air voice for this mix was 2.5%. This is a 75 gyration mix. The final asphalt content of the design was 575. That came from virgin binder, 437% from the virgin binder, and then the 1.38% that came from the binder contained in the wrap. So a little bit about what we saw from this section. This section was actually built on August 24 of 2018. Paving operations started at approximately 10 a.m. And I'm providing this information to give you an idea of the temperatures that we were dealing with during paving in August. So if you look at the temperatures that day, the high was 85 and the low temperature was 67. So in order to monitor the cooling rate of that mix, we placed thermal sensors that were embedded in the pavement to see how that mix was cooling over time. When we conducted that analysis, we found out that it took approximately 6 hours for that mix to cool from 242 degrees Fahrenheit to 175 degrees Fahrenheit at the mid depth. What we found when we were doing this evaluation is that, of course, the top is going to cool off first, but as you go down within the pavement structure, it takes longer for that mix to cool. This is something that you guys here had already realized. So here the recommendation is, try to pave at night on where the temperature is not so hot. When you guys have done here that, probably the time it takes for that mix to cool will be reduced by 2 hours at least. When we placed this section, we didn't have any issues to achieve compaction. We were using the same compaction equipment and the same rolling pattern that we were using for the other sections that were built back in 2018. So no really issues there to achieve compaction. As you can imagine, when you're placing a layer that is that thick, you're going to have issues with ioride. So what we did here and what you guys have done in the past for this stick lift is to grind the sections. Just to give you an idea of the numbers that we were dealing with, right after paving, the average ioride was close to 400 inches per mile. Once grinding was applied, that number was dropped to about 100. So a significantly drop in that initial number that you have. Pretty effective technique to bring that section back to acceptable riding conditions. So as I mentioned, this section has been in place now for more than 20 million easels. The information that I have here is the information that we gathered at the end of cycle number 2 that ended last year. So 20 million easels, this is rotting information. You can see that rotting right now is at approximately 0.3 inches, and it has remained constant over the past months. So there is not really a concern that this section is going to have issues with rotting. The ride quality, as I mentioned, after grinding, that number stayed at about 100. There has been a tendency overall on the average ioride numbers to drop a little bit. This may be the result of the smoothing effect that traffic can have when you start with a pavement that is relatively rough. That's something that we have also observed when you are trying to place an overlay on top of rubberized concrete. So we saw a little bit of a decrease in the ioride numbers over time from the time that mix was grind at the beginning, right after construction. Cracking we started noticing a little bit of cracking at the end of cycle 1. As you can see here, if you look at where we are right now in terms of percentage wheel path or lane area, if you look at the lane area, we are at about 8% cracking. What you have to realize, and we want to point out, is that if you look at the cracking that is happening, it looks like a big number, but the extent of the cracking is very mild so far. So even though it has cracked some, the nature of the cracks, this is a top-down cracking, and the severity of the cracking is still very minor. So some of the recommendations at the completion of the previous cycle, we found that building an 8-inch thick leaf is a viable alternative. We had very good compaction in the field, no issues to achieve compaction. You have to realize that careful considerations should be given to the time that mix is going to need to actually cool off. I mentioned some of the things that you guys are already doing, paving at 9, making sure that you do those construction projects when the temperature is not so hot. Smoothness may be an issue, but once again, grinding techniques have shown that can be overcome. Rotting is not a problem. As I mentioned previously, rotting was one of the main concerns that we had regarding building a section that thick at once. But after more than 20 million easels, rotting is not really a concern. As I mentioned previously, by the last plot that I showed you, top-down cracking is growing in extent, but not in severity. You saw from the beginning at the end of cycle 1 at about 2%. We are at 12%. But the severity, if you have the opportunity to walk our sections, is very mild. Ride quality improved over time. We started with that 100, and the numbers have stayed approximately 15 inches per mile lower than when originally placed. There is no evidence that there is bottom-up cracking on this section. And because of that, and because of the severity of the cracking that was observed, it was decided to leave this section in place for another cycle to continue monitoring the health of the section and make sure that we understand how the crack is developing over time. So that's what I have regarding this section. Once again, we're going to put another 10 million easels on this section and see where we are at the end of this cycle. The second section that I mentioned that South Carolina DOT is sponsoring is a new test section. The section is S8 on the test track, and the objective that we have with this section was to design, build, and evaluate the performance of an SMA with dried ground tire rubber added during production as a mix modifier. So we want to provide alternatives for South Carolina DOT to be able to produce SMA mixes without the need of a polymer binder or cellulose fibers. So we are replacing the polymer modified binder and the cellulose fibers with the use of ground tire rubber and see if we can provide equivalent performance to what you currently have for your SMAs that are widely used here in the state. So to be able to conduct this experiment and to try to simulate a typical South Carolina DOT structure, what we did was to build a 6-inch thick lift underneath the SMA layer, once again to simulate a typical mill and fill that you currently do here in South Carolina. So typically you're going to have, let's say, 8 inches of asphalt. You mill 2 inches and you place a new SMA. So we were trying to follow a similar approach to be able to evaluate the performance of the SMA layer. The thick lift that we use has a base layer, was the same mix design as the lift that we placed in the 2018 cycle. So we already had that mix design that had worked well. So we used that same material, same mix design as the one used in previous years. So a little bit of information about the mix design with the ground tire rubber. We started with a South Carolina DOT 12.5 nominal max SMA mix, 220 pounds per square yard, or approximately 2 inches overlay. 35 gyrations You have to understand here that we started with a base mix design without the rubber that was selected from a mix design that was developed at the NCAT for another study that was conducted for South Carolina DOT. So a couple of years ago, South Carolina DOT sponsored a research project where we were looking at developing durable SMA mixes in our lab. So that base mix that we use as a starting point was selected from the group of mixes that we tested previously. So this original mix that we used had a PG 76 minus 22 with 0.3 cellulose fibers. For the new mix design with the ground tire rubber, the binder was a PG 64 minus 22. We used 0.5% Evotherm P25. The aggregate that we use for that design is a combination of South Carolina granite. The mix had 6% fly ash as well as 1% hydrated lime. The ground tire rubber, dry ground tire rubber that was added was a product provided by Lehigh. Microdyne 400 TRXP is the name of the additive. And we added that rubber at a rate of 10.5% by weight of the virgin binder. This is a mix that doesn't have any wrap. So as you understand, when we are doing this type of new designs in our lab, you have to run several trials. And I'm going to try to simplify a lot of the trials that we have to run in our tests, in our lab. We started with an original mix design that was pretty rich because when those mixes were proposed, we were trying to look at a very durable mix that had very good, very rich asphalt content. So the starting point of that mix had a 6.4% asphalt content. That was the mix design that we developed, and the TOT was pretty happy with the results that we showed. When we conducted the modified design with the ground tire rubber using a similar gradation as in the original design, we found that when we were using a 6.4% asphalt content, the air voids actually dropped from a 3% that we have in the original design to 1.9. At this point, South Carolina DOT didn't feel so confident on keeping this mix with lower air voids like that. We've seen sections in the past place with air void levels of 1.9 or 1.5, and they have worked well, but there was a little bit of hesitation to go that low. So we decided to adjust the binder content and drop it to 6% from the original design. With that, we were able to bring the air voids to 2.9%. So currently, the specifications call from 3 to 4%. We were allowed to drop that number to 2.9, and with that, South Carolina approved to continue the evaluation of this mix at 6% asphalt content. So when we were developing the mix design, we want to make sure, as I mentioned previously, we are not going to be using cellulose fibers in this mix. So we make sure that we had good drain down numbers. We ran drain down at 2 temperatures, 310. That is the typical production temperature that you have here for SMA. At a higher temperature as well, 335. And we did not find any issues meeting the drain down requirement of 0.3% that you have in your specifications. We also run performance tests. South Carolina is currently not one of those states that is, at this moment, running balanced mix design, but it's always good to run some performance tests to understand how the mixes are doing. And you also have to keep in mind that we started with a mix design that we were pretty happy with, an SMA that was using a 76 minus 22 binder. So we want to see what kind of numbers in terms of performance tests we were getting as we were switching from a 76 minus 22 binder to rubber with a 64 minus 22 binder, also dropping the asphalt content because of the issues that I previously mentioned. So we run Hamburg tests. We run the Cantabro Hamburg for rotting evaluation, Cantabro for durability. In terms of cracking, we decided for purpose of evaluation of this mix design to run the Texas overlay test, looking at the crack propagation progression rate. We realized that what we've seen for SMA mixes, when you are testing these mixes with the ideal CT, SMA mixes tend to give you very high numbers. So we were trying to find a potential candidate in the lab that will be able to discriminate the performance of these SMA mixes. So if you are running ideal CT and you get a 300 compared with a 250, is that better or worse? So we were thinking that the OT for what we have seen is a test that may lead you to a better assessment to discriminate this type of mixes. There is currently no criteria here in South Carolina, as you can imagine, for DOT. A preliminary criteria has been developed for Texas using DOT. They are looking at a CPR of less than 0.45. You have to realize that by looking at this OT parameter, the lower the better. So right now the threshold that they are trying to target here is 0.45. So as I mentioned, we run Hamburg. We didn't have any issues to meet the Hamburg. The rubber mix had a little higher Hamburg than the original design with the 76 minus 22, but still way below ranges that are recommended. Cantabro has well no issues. Once again, South Carolina DOT doesn't have a criteria to tell you what is a good number, but if you look at other numbers that states are doing, Virginia, for example, used 7.5 as a criteria. That's the limit, and we are there still below that limit established by other agencies. Looking at that OT number, as you can see from the results, the original design had a better number in terms of OT. The number that we got for the rubber mix was slightly above that preliminary threshold that has been developed for Texas. But at this point, us, as well as South Carolina DOT, felt pretty confident with this design. We realized that even though this criteria has been set for other states, it's a number that is not set in stone. Something that we, like I say, we felt that this was a good design, and we decided to go ahead and proceed with this design for construction. Construction of the thick leaf that was placed underneath the SMA rubber mix took place on August 19, 2024. Some pictures here of the placement of that mix. No really issues to achieve compaction. That's something that we had already experienced with the previous thick leaf at the test track. The next day, we placed the SMA with the ground tire rubber on August 20. You have to realize is that when you are producing a section with the ground tire rubber, you need to have a special unit to feed the rubber into the mix during production. So that's a unit that we have on site, not only for this section, but several other sections that we were producing at the test track. The section was tack coated. We went ahead and placed. No issues to achieve compaction. And you can see here a little bit the final product of the mix that was placed. I'm providing here a lot of information regarding the design itself. As I mentioned previously, what I'm trying to point out here, this is the current South Carolina DOT specification for the 12.5 SMA. You have the design that we got for the ground tire rubber mix, and then you have here the results that we got during quality control. As you can see, no issues to achieve any of the aggregate or aggregate size requirements. We met all the requirements that they have in terms of gradation here. As I mentioned, the asphalt content for this section was 6%. We matched that during production. In terms of air voice, we dropped during production that air voice that we had of 2.9 to 2.7 a little bit. But but not really a big concern at this point. The other volumetrics, no issues really to meet those volumetrics. So we were pretty happy with the quality control results that we got. The final has-built thickness of the SMA section was 2.1 inches. We were able to achieve an in-place density of 95.3%. And one of the things that we've been pretty animated at NCAT is to make sure we understand what happens with performance test production mix results. So during production, we sampled some of the mix to see what kind of numbers we were getting for the performance test. We ran a hammer for the plant mix, compacted hot in the field. For that, we got 6 millimeters of rotting at 20,000 passes. Still, once again, no issues there with the rotting. We didn't run OT because of the complexities of the test itself, but we did run IDLCT. Remember that I told you we were trying to do a little different during the design, including the OT instead of the IDLCT for what we've noticed with the IDLCT. But during production, we prepared some pills and ran IDLCT. The average CT index number that we got for the mix was 300, around 300. So at this point, we do not have any concerns about the mix. What is left from us to do is to continue monitoring the performance of this section, and at some point working with the DOT to help draft specifications if the mix does really good on how these mixes can be used here in the state. So current cycle is ongoing. As I mentioned, we are trafficking these sections. We will continue monitoring those two sections and the rest of the sections for the duration of the test track cycle. We are currently at approximately 0.8 million ESALs, so we are getting close to reach that 1 million ESALs of trafficking. So that's what I have regarding the South Carolina sections. They told me I had about 45 minutes to talk to you, and they said you can dump in some other things that are of interest for the people that are attending the conference. So I'm going to spend a little bit of time talking about some other things that we are doing. The ground tire rubber section that is placed here from South Carolina is not the only one. Besides the South Carolina ground tire rubber section, we are looking at our test track to other test sections that have been sponsored by different state DOTs. So besides the South Carolina SMA mix, we are also looking at a section that is being sponsored by Arkansas DOT. We are looking here at a gap-graded mix with pre-swell ground tire rubber. The goal that Arkansas has is to be able to have an overlay, a premium overlay that will allow them to mitigate reflective cracking that they are dealing with from rubberized concrete. They're having a lot of issues with reflective cracking from those old concrete pavements, not only from the rubberization process, but also from the joints. So they place an overlay, and those overlays don't really last that long. Virginia is also evaluating dry ground tire rubber. The experiment here is a little bit different because they are evaluating two dense graded mixes, one with SBS and one with dry ground tire rubber. They want to see if the ground tire rubber can have similar performance as the SBS. And they are dealing also with some other conditions underneath that overlay layer as well. We are also conducting long-term performance evaluation of sections that were placed in the previous test track cycle, 2021. So Oklahoma in 2021 sponsored a section with dry ground tire rubber. The objective for them was also to mitigate reflective cracking that they were dealing with. And some of you may be aware, but we are also, in terms of long-term performance evaluation of ground tire rubber products, we are looking at dried and wet ground tire rubber as part of the additive group experiment. Some of you may be familiar with the additive group experiment. So since I'm mentioning here the experiment with the additive group and ground tire rubber, I'm going to spend a little bit of time talking about the additive group because it's something that is of interest for several agencies, state agencies. So what we are doing with the additive group experiment is what we call a multiple section experiment. So we are looking at sections that were built with rubber modified technologies. In this case, wet and dry technologies were used. The same with plastic. Plastic was added dried and wet. We are looking at a section that has fibers, and then we have also our control section, which was an SBS 76 -22 section, the standard SBS modified that a lot of states are currently using. So these additive group sections were built at the NCAT test track back in 2021. What you have to realize that all these additives that we are currently evaluating at the NCAT test track, they were also used on sections that we built in Minnesota with our partners there. So we're going to have performance evaluation of these additives not only in the south, but also in the north, in Minnesota. So if you look at the overall objective that we have for this multi-experiment, is to be able to comprehensively evaluate the performance impact that multiple additives have at the same time. We have all these new additives that are coming and making that are becoming available in the market. So we want to understand what those additives are going to do to the mix. Bottom line of our research is to be able to establish a process to evaluate additives, so we don't have to build a test track section every time a new additive wants to be evaluated. Overall, we want to support our goal of providing sustainable payments that at the end will outperform materials that we are using currently. So I promise I'm not going to get into a lot of information about the additive group. But what I want to point out is that for these different sections that we built, all these sections were built equally, with the only difference being the additive or the modified binder that was put in the asphalt layer. So all these sections were built of the same structure. You have the same subgrade, same base material, same thickness of the asphalt layer, once again with the only difference of what was the additive that was included in that particular section. So we are looking at 6 different sections, including the control. A lot of information was shared regarding performance tests, structural evaluation we are doing with these sections at the test track. What I'm going to try to summarize right now is where we are in terms of performance. That's what typically people like to see. How are those sections doing in the field, right? The sections were in place. They have been in place for a cycle now. We are in cycle number 2, so 10 million ESAs were applied in the last cycle, and that's the information that I have here. In terms of cracking, I'm going to go ahead and tell you before I talk about cracking, these sections, they didn't really experience any issues with cracking, with rotting or iorite. So I'm going to try to focus everything on how the cracking performance of this section was. This was an experiment that was intended for the sections to actually fail. That's something we always like to point out. When we build these sections, if you want to be able to develop a procedure on how you're going to evaluate these different additives, you don't want to have all the sections and at the end of the cycle being all performing well, right? Because there is no distinction. There is nothing that you can make out of that. So I like to point out that the thickness that was used for those sections was intended to give us cracking at the end, okay? So if you look at these sections currently, or when 10 million ESALs of trafficking were applied, the fiber section had no cracking, the SBS control section had no cracking, and the wet plastic section had no cracking. So those 3 sections out of the 6 sections had not experienced any cracking, that is section including the control section. If you look at the dry plastic, the end of the cycle, it had 2.8% cracking. You can see here when the first cracking was manually observed. Manually observed is when a person with experience goes there and walks the section and they notice cracking developing of the pavement. Very often, these cracks are very, very, very hard to see but that's when the first crack there was detected. Then the pathway van was able to detect that first crack at approximately 6 million E-cells, but once again, this section is still doing pretty good. When we are looking at the rubber sections, here I'm showing you the performance in terms of cracking of the rubber sections. The wet rubber at the end of the cycle had approximately 5% cracking. The cracking was a low severity cracking, as you can see here. I'm saving the worst for last. So you have about 5 there. When you are looking at the dry rubber section, you have the first crack that was manually observed of approximately 2.5 million E-cells. So after 2.5 million E-cells, we were able to see very minor cracks to start to develop on this section. That cracking didn't progress very fast, and in some cases was even we were going there and we were not able to see them. But over time, the cracking was detected by the pathway band. So that happened at approximately 3.5 million E-cells, and the cracking has continued to progress since then. Something that you have to, I would like to point out is when we did a little bit of forensic evaluation on these sections, we found that the granular base on the ground tile rubber dry section was relatively lower than that of other additives. So there is a paper we are about to publish at TRB where we do more analysis looking at the effect of having a weaker base on the performance of these sections. Once again, we are in the process of monitoring what's happening for these sections in the remaining of the cycle. Just to kind of wrap up this presentation regarding the additive group as well, we published our test track report of the previous cycle completed last year. You also have the code there to download that whole report. Is pretty long, so it may take you a little bit of time if you want to have that report. But it's also available on our website. All the information related to the additive group is included in Chapter 3. It's about 80 pages, so pretty good read for tonight for your homework. If you want to learn a little bit more about that. Because once again, what I'm trying to show you here is pretty much just the highlights. I'll probably pique your interest so you can go there and find out more of what we did there. As I mentioned previously, trafficking on this current cycle started last year in early November. The sponsors decided to keep all these sections in place. As I told you previously, 3 of these sections have not cracked yet. We're trying to create that distinction between the different products. We realize that some of these sections may have to be replaced pretty soon. We right now had a big patch on the dry rubber section, but we anticipate that in this cycle we're going to see way more crack where we can actually establish distinctions and make a better assessment of what type of process we're going to recommend for future evaluations of asphalt additives. Okay? I think that's all I have. Hopefully it was enough information for you to digest for 45 minutes, or I don't know how long it's been. But I'm going to be here if you have any questions. I don't know if we have time for questions right now. Awesome.
All right. Can we give a big round of applause, Mr. Rodezno?
Appreciate it.
A small token of appreciation for speaking with us.
Thank you so much. Thank you so much. They always say that there are 2 things. One, it was either something really good that you heard, or people had no clue what you were talking about. So hopefully it's the first one. Thank you, guys.